So this is the third part of our pre-chapter 6 material. And again, a little warm up just to review. So we have 3 problems today. See if you can apply the properties of radicals to simplify A, root 48 over root 4, B, 2 root 45 minus root 80, and then C, cube root 24 over cube root 3. So try and apply the properties of radicals to simplify those 3 radical expressions. So next week, we will be solving equations containing variables of larger powers, and we'll need to use the process of one of these radicals to help us solve those equations. So number 1, there's a couple of different ways that you could approach number 1. The square root of 48 over the square root of 4. Depends on what you see first, but I'd say A, not number 1. A and C are similar to each other for sure because they're both division. So that's the quotient property. B is what we did yesterday. Lacey, what did you do for part A?
I put 48 divided by 4 under 20.
Yeah, so that is the quotient property. If they're individually under the same radical, they can then combine together under one of them. And Lacey, that becomes? 12. There we go. The square root of 12. So that is one thing that you could do with them. And then after you have that square root of 12, Lacey, what goes into the square root of 12?
The square root of 4 and the square root of 3.
Yeah. So 2 root 3. Quotient property. As long as the index is the same, you can pull them underneath the same radical or one radical. So part B, we have 2 root 45 minus root 80. Ava, what'd you do with that one?
So I put 45 into the square root of 12 and the square root of 3.
So 45 breaks down square root of 9 and 5. And then how about 80? Yeah. Remember, you want the largest perfect square that goes into a number. So Ava, when you simplify this part, what do you get?
6 square root.
And then you're subtracting?
Minus 4 square root.
Yeah. So we end up with 2 and then root 5. Remember, the radical must be identical. So the number underneath has to be the same, the radicand, and the index must be the same for us to subtract the coefficients in front. And you're just subtracting the coefficients in front. So Jaden, sorry. The last one here, Jaden, what do we have? What'd you do with the cube root?
Well, I did it a different way that you don't pull it under the full thing, but I took 24 and I put it into 3 root 8, and then, well, not 3 root 8,
yep.
And then cube root 3.
Yep, that works.
And then I ended up simplifying that to 2 cube root 3. And then I did over 3 root 3. Cube root 3.
Yep.
And then can that cancel out?
Yeah, it's the same. So if you chose to simplify it this way, and again, it depends on what you see in the problem initially and how you want to approach it. So she took the numerator and said, let's break that apart first. But if you have a radical that is the same on the top and the bottom, they cancel. So that would just be 2. So that's one way that you can work through the problem. The other way would be to pull it together. 24 divided by 3 is the cube root of 8, and then that 2 comes out. So in that case, you're taking the root 3 just out of the problem immediately instead of canceling it separately. But you get the same answer. We could have done part A very similar as well. So we could have just broken down the square root of 48 first, and then simplified from there. So multiple ways to do the problem. As long as you're doing correct algebra, you don't want to go to algebra jail. I have algebra jail. It's under my desk over there. You don't want to go to algebra jail. But as long as you're using the correct algebra steps, you should still get the same solution. Simplified radical. Questions? All right, so we're going to do some multiplying today. Adding, subtracting, multiplying would come next. When you learn operations, you learn adding first and then subtracting and then finally multiplication and division. My daughter in 4th grade is doing long division. I feel like it's finally. In the middle or the elementary school, they're, in my opinion, really dragging their feet in math. She's good at math. So as a mother of a daughter who's good at math and they don't have them separated for math, it's driving me crazy. That's okay. We just give her extra work to do. Lucky for her to have a math teacher as a mom. She comes home, she's like, I didn't have any homework. I'm like, you didn't have any homework? Oh, we'll find homework for you to do. Don't you all wish you had a math teacher as a mother and an English teacher as a father? Double whammy for my kids. All right, let's look at letter A. So it looks similar to problems that we did in chapter 4 and chapter 5. Looks like multiplication. We have square roots. When you multiply square roots, it is okay for the number underneath not to be the same. Just like when I multiply variables together, I can multiply an x and a y together. I cannot add them, but we can multiply them. When you multiply radicals, the index still needs to be the same. So if the index isn't the same, we cannot multiply them. The number out front is the coefficient. The coefficients get multiplied together and the radicands get multiplied together. So essentially, if it's outside, you multiply them. If it's underneath, you multiply them. And this is just distributing. So we're going to look at the 1 times 4, and we know that's just 4. It still stays as a radical. It still stays as a square root. And then 3 times 2 is 6. So now this is 4 root 6. We have a subtraction sign. I have 1 times 1, so that's going to stay as 1. And then 3 times 12 gives us the square root of 36. If you can simplify after multiplying, then you need to do that step as well. Gabby Soul, is there any way we can simplify our expression as we have it right now? Yeah, what is the square root of 36? 6. So 4 root 6, and then just minus 6. That's as far as you can go because these are no longer like terms. You have a radical and an integer, just a number. So this would be our simplified answer. So that's distributing, using the distributive property with radicals. If you look at B, what does it look like you would do with letter B? What method do you think you'd use here? Ella, how would you think you'd multiply them? FOIL, yeah, we're still going to FOIL. These are binomials, 2 terms, multiplied by 2 terms. So we're going to FOIL these. Again, multiplying them, the numbers underneath. So this gives us the square root of 25. 2 is outside. The square root of 5 is underneath. When you're multiplying them, you're just going to write them next to each other because that's also multiplication. 2x is 2 times x. So 2 root 5 is 2 times root 5. And then we have minus 5 times root 5, so writing them next to each other. And then our last numbers, negative 5 and 2, give us negative 10. So we're FOILing those, just like we would FOIL any problem involving variables. Ella, what would you do next after FOILing? Yeah, so this becomes 5. What else can we simplify then?
The middle two terms could become -3 through 5.
And then we have a 5 and a -10, and that gives us -5. So -5 and then -3 root 5. Questions?
Miss Kane, does it matter how you write it?
It does not. No, that's a good question. So if you have the radical in front, that's okay. If you have the -5 in front, I try and pull the numbers in front and keep the radicals in the back, but it does not matter. Good question. Either way. So see if you can try letter C. Square root 2 minus square root 3 times square root 2 plus square root 3. See what happens with those. So Gabby Snyder, when you take a square root of 2 times the square root of 2, what's that make? And then what do you have next? Good. Awesome. And you're so close. It's going to be a minus square root of 9 because of that negative sign right here. So the square root of 2, or I'm sorry, the square root of 4 becomes 2. The middle terms, a positive and a negative, cancel. Our last term is the square root of 9, which we know is 3. So that's going to go down to -1. Notice when you take the square root times itself, a square root of 2 times a square root of 2, that just becomes 2. It simplifies down to 2. A square root times itself, they kind of cancel each other out. They undo each other because you now have a perfect square. So that just goes down to the number 2, and that's going to happen every single time. If you take a square root times itself, it's going to simplify down to just be that value under the radical. So let's look at letter D. We have a quantity squared. Ava R., what does it mean when you have a quantity squared?
The parentheses, like everything in parentheses is multiplied by it again.
Yeah, it's multiplied by it again. There are 2 of them. It's being written twice. There are 2 of those quantities. That little 2 does not distribute through. It's saying there are 2 of that entire quantity. And then Ava, when you multiply, we have the square root of 5 times the square root of 5. We now know that just becomes 5. Yeah, so you don't need to write the square root of 25. That's going to become 5. What then happens, Ava? What else? Good? Nice. So if we pull our numbers together, 5 and 1 makes 6. A square root of 5 plus a square root of 5, Ava, what does that make? What's x plus x? What's x? There you go. So square root of 5 plus square root of 5. There are 2 of them. So 2 root 5. Questions? So the last 2 problems here, letter E looks kind of tricky. Lots of radicals going on. Just make sure you're multiplying the pieces together. So the outside numbers, you're distributing through. Outside gets multiplied together. Underneath the radicand, it gets multiplied together. So this would be 10 root 12 and 15 root 10. So So again, outside numbers and the inside numbers are getting multiplied together. And then before you move to the next problem, could it be simplified? Can it be simplified? If it can, you need to simplify it. Julia, is there any part of letter E that could be broken down any further? Yeah. And then the square root of 4 becomes 2. So the square root of 4 becomes 2 times the 10 makes that 20 root 3. And then 15 root 10. Square root of 10 cannot be simplified. There is not a perfect square that goes in it. Questions? So just make sure that your final answer is still simplified. Even though you multiply, doesn't mean you're quite done with the problem if a radical can be broken down. I cannot add them together because they don't have the same like term, like radical. So the last one on this side, another quantity squared, just like letter D, except I have the square root of 6 minus the square root of 2 quantity squared. So let's write that twice. So anytime a quantity is squared, that quantity is written twice. There are 2 of them. Jaden, what would you get when you take root 6 times root 6? 6. Good.
Sorry, negative root 12.
I knew what you meant. You're good.
And then, and positive root 4. Oh, wait, I said wrong.
Yeah, we need a negative square root of 2 times square root of 6.
Oh, and again, negative root 12.
Yeah, that's all right. And then the last one, negative root 2 times negative root 2 is positive root 4, or just 2.
Oh, yeah.
You're good. So if we combine our like terms, 6 and 2 make 8. There are 2 negative root 12s, so there are 2 of them. So now I have 8 minus 2 root 12. Any other simplifying? Gabby. Nice job. Good. Excellent. Questions? Not so bad, right? I mean, it's like multiplying with x's. So just like every other day so far this week, we worked with the radicals and numerical values. And then we did throw in some x's because we have to have variables in algebra. That's what makes it algebra. So before we move to the next group of problems, are there questions on these 6? Anybody at home have questions as well? We did go through them kind of quickly, especially when we got to the end. So then the next group of problems have variables. So if we can multiply radicals with numbers, we should be able to multiply radicals with variables. The same properties apply when you multiply variables together. So if you look at letter A, we're going to use the distributive property. But underneath is 3x times 2x, and you're still multiplying to them together as if it said 3x times 2x. So outside is a 4. That's going to stay outside. Underneath the radical is 3x times 2x. Ella, what does 3x times 2x make? Yeah. Same property of variables. That's now 6x squared. And then Ella, 3x times negative root 12. Right. All right, so that's step 1. We distribute. Step 2 is to make sure it's simplified. If you look at the first one, we have the square root of 6x squared. Ella, can that be simplified in any way? So if I look at this as the square root of 6 and the square root of x squared. thinking about them as two parts. Which one of those? Yeah, exactly. So the x squared, the square root of x squared is x. So that comes outside exactly as she said. So this becomes 4x. We cannot do anything with the square root of 6. So it's going to stay underneath. There is then a minus sign. And then if we look at the next part, we have the square root of 36 and the square root of x, thinking about them as two parts. So Ella, the square root of 36 becomes 6, and then the x stays inside. So these are not like radicals. You cannot combine them together any further. But we could at least simplify the radicals that we had initially. So see if you can look at B. B looks like a foiling problem. So try and FOIL those together. Remember, you're really keeping the square root and just multiplying the terms underneath. There's only an extra step here because they need to be simplified then. So that would be our extra step. Radicals have to be simplified. So the first line, what do you have for E when you multiply, FOIL? Good. And then, can any of them be simplified? Nice, it kind of flip-flop there. So the square root of 9 becomes 3, but the x stays underneath. And the next one, x squared, the square root of it becomes x, but the 3 stays underneath. And then we have minus 5 root 3 minus 5 root x. So there's a lot of stuff to look at here. Are any of them exactly the same, so they're like terms that we can add them together? So look at that whole list. For it to be exactly the same, it has to have the same radical.
So, the first and last one was the X, and then the middle two, right?
So the first and the last one, we have root x and root x. So 3 minus 5 becomes negative 2, and then root x. Now, the next two, yes, as she said, they are the same root 3. But because there's an x in front of that first one, we can't truly add them together. We can write them next to each other. So I could then write the x root 3 and the minus 5 root 3. Yes, they are the same radical, but I cannot combine an x and a number together. But the first and the last one, we can because they're coefficients in front with that same radical behind it. Questions? All right, so 2 more on here. Anyone at home have questions? And apparently I skipped letter C in this problem. Gotta fix that for next year. This should be letter C, not B. I guess I liked B. So thinking about that property, we have the square root of 2x minus 4 and the square root of 2x plus 4. Lacey, if we multiply the square root of 2x times the square root of 2x, what does that become?
The square root of 4x squared.
Yeah, square root of 4x squared. And then Lacey, the square root of 2x times 4. And then -4 square root of 2x. And then what's the last term there, Lacey? -16. So notice that the middle terms here, we have a 4 root 2x and a -4 root 2x. They cancel. Lacey, what does the square root of 4x squared become? Yeah, that just becomes 2x. So 2x minus 16. So just looking at this problem, we took the square root of 2x times the square root of 2x. That radical is the same. When I multiply the same radical together, I just end up with the 2x. The other thing, if you notice the middle terms canceled, sorry, this is supposed to be a plus here. Those middle terms cancel because you have two quantities that you're multiplying together that have opposite signs. They're the same quantity, but one's a minus and one's a plus. That'll always happen. Those middle terms will cancel when you multiply a quantity together. They're called conjugates. So they're the same, but opposite signs. And that's going to happen. So you'll see that they will cancel every single time. So the last one here, we have the square root of 3x plus 2 quantity squared. And again, we know that a quantity squared means there are two of them. So write it a second time and then see if you can multiply that together. What do you have, Julia? Good. And then that first term, square root of 9x squared becomes the middle terms. And then, awesome, nice job. Does anyone have questions? Anyone at home have questions? I think out of all of my classes, you guys hands down are good at asking questions even when you're at home. You don't hesitate to just call something out and ask. Even my honors check and pile classes, they don't quite do it as much as you do. So I commend all of you for not hesitating when you're at home to still ask questions. Continue to do that. So instead of doing those bottom problems, why don't we just start the homework? I mean, that makes more sense, right? Get some time to start the homework. So I'm going to open up Google Classroom and get this assignment posted for you. So today's worksheet is multiplying. And as I said, tomorrow we will be dividing. We'll get the last concept kind of pulled together this week with all these radicals. So if you go to Google Classroom, the worksheet should appear momentarily. So it is now up on my Google Classroom, which means if you refresh, it should appear on yours. And it is called multiplying radicals. So just like the problems that we have done, it's broken into two groups. So the first group would just be the numerical expressions with the radicals. And then the second group would be our variable expressions. And the last group, I threw in some review problems just to kind of keep reviewing. So the last group of problems here I added were just simplifying with variable x and radicals. And all the ones that we have, except for I think that last one, they're all square roots. We could do this with cube roots. We could do it with fourth roots. I just kept them as square roots. So if you're at home, if you have questions, please ask. Otherwise, you are free to go, continue working on this as you have time in class, but you do not need to stay on Zoom. Have a great day, and I will see you tomorrow if you're at home. Those
Have
of
a
you
good
in-
day.
Thank you, you too. See you later.